Hi everybody, so this is the video about what we are calling now the graphical exploratory analysis module of the QD. So if you're getting in right now into the group, I'll give a very brief idea of what the QD is, but again, we have a lot of other videos about this. The QD stands for question diagram, and it's basically a way to standardize the formulation of hypothesis-driven research questions. So this detail is pretty important. Now, basically what this means is that every time you're formulating a hypothesis-driven question, you have to have three components that we outline in a page. Okay, so these components are the hypothesis, or the hypothesized conclusion. There's a reason for this. I won't go into this. The variables that relate to the hypothesis or the hypotheses, and the mock tables and graphics. Now, again, I won't go into the details of this, but basically, once you have this structured, you will make sure of, you will be getting two things out of this. Number one, you get the internal consistency of your research question, right? Which means that all of these three components will be agreeing with each other, and you have a way of communicating with the quantitative people. Okay? So basically, you're statistician. Now, very important, as I said before, QGs are about hypothesis. Okay, so and this is a good thing. This is the classical way, like I was trained, and most people in clinical research were trained. You have a hypothesis, you avoid what most people would call fishing. By having a hypothesis, you're not going to be finding things that don't exist, or you're going to be less likely to find things that don't exist. Again, I don't want to get into the theoretical discussions about this, but one big point is that by focusing on hypothesis only, you're missing something. Again, I'm not stimulating people to fish over the data, but if you want to start exploring your data set and later on using very robust statistics to see whether that exploration is, you know, resulted in something of value, you need to explore the data. So basically, the idea for the graphical exploratory analysis module of the QD is to add an exploratory, an innovation, a discovery, if you will, module for these research questions. Now, how do you do this? Well, basically, whenever you go through books or texts, papers in relation to exploratory data analysis, you basically have three things that you have to define. And this is fairly similar to what you have the curiosity later to the way we outline our question diagram. So number one, you have to define what are your outcomes of interest. So which variables, do you want to say predict, or are you interested in? Number two, you have to define your predictors. And number three, you have to define your strata. So I'm going to give you some completely made up examples, just so that we can get something a little bit more tangible. So let's say that in one given data set, you have your data dictionary. So the data dictionary is the list of variables in their definitions for everything that you have there. And basically, you want to explore this without the previous hypothesis. Okay. So basically, what you're going to do is to list every single variable that could be an outcome. So I could have something there that would be like, for example, death. Okay. I could have something like, post-operative complications. I could have something like, cost. So I could have a lot of different things. Very important, whenever you're doing an exploratory data analysis, besides coding all or writing down all the different variables that you have, you should also outline how can they be measured. So for example, death could be measured, for example, whether a person died or didn't die, yes or no. It could be measured as time to death. It could be measured as, for example, 30-day mortality. Could be measured as other periods of mortality. Could be measured like intra-operative mortality. So bottom line, the main point here is that for each of the variables that you select as your outcome, you basically categorize them in any way you would like. Okay, and then you do exactly the same thing for the predictor. So okay, I think that age could be a predictor. Whether patients have a certain disease, and then I could have multiple diseases. Again, you name it. And then, maybe you could also break this down by different strata. So, okay, I want to know whether, people of a given race or ethnicity are different, whether certain age categories could be different. And here, very important, as you can see, something could be a predictor and a strata at the same time. Something that we do not allow in a question diagram, at least for a given hypothesis. Okay? Now, very important, keep in mind that for each one of these categories, and by categories I don't mean variables, I mean really like, okay, death, yes or no, time of death, blah, blah, blah. Let's say that, between variables and categories, you have something like, 10 different variables here, 10 different predictors, and 10 different strata. What this means is that you're going to be multiplying all of these, so 10 times 10 times 10, you are going to end up with, 1,000 different graphics showing the relationship out of this. So it's truly exploratory. And you have to be careful again later on. We're not going to go over this now, but careful so that later on, whenever you're testing whether this exploratory data analysis really generates something that is valid, it's not just a fishing expedition, you use the appropriate statistics. Now, how do you do this magic? How can you, come up with 1,000 graphics? Well, so here, this is something that I have been emphasizing to the data mining group, which is the importance of using scripts. So I know a lot of people are like, well, writing scripts, I don't like to write code. But as I mentioned before, there are at least two huge advantages to the use of scripts. The first advantage is reproducibility. Later on, you know exactly what you did. And the second advantage, which comes in handy right now, is about automation. And what I mean by automation is that I won't go over the details of how to do this now, but is that for something like this table with 10, 10, 10, say 30 different variables, I could create 3 vectors. Later on, we're going to see what this is. But the different types of death and blah, 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 each one of them. And then another vector for predictors, and another vector for different strata. And I can use some statistical packages to simply cross them and save 1,000 different graphics. And then, you can go over these graphics, and these graphics will have an annotation about in which ways these associations actually generate something that initially looks interesting. Again, this is not going to be the final thing. There's a lot to be said about how to validate graphical or exploratory data analysis in general, but the idea is discovery, to not restrict yourself just to things where you have previous hypotheses. So in a future video, then I am going to, demonstrate how you can do this with a package from the R language. And we're going to see how this could be automated in a very, very simple way. Okay, thank you. Bye.